So 6.3 has to do with more similar figures, and you might be wondering, some of you might be wondering why we're going from 6.1 to 6.3, and I mentioned once before the reason for that is because the transformation stuff that includes translations, reflections, and rotations and dilations, that's something that we're going to come back to. So we're kind of grouping all that together, and anytime we see something that has to do with transformations, for now we skip over it, but again, we're going to go back to that stuff. So in our previous chapter 4 with triangle congruence, we talked about some 3-letter acronyms, side, 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 theorem, and other ways to show triangles are congruent. What we're going to do here is we're going to show that triangles are similar even if we only have some of the information about those triangles. And so you'll notice here the first similarity shortcut, kind of like how we called them triangle congruence shortcuts, the first shortcut is the angle shortcut, okay? And what this means is that if you have two angles in one triangle that are congruent to two angles in another triangle, regardless of how big or how small those triangles are, then we can safely say that the triangles themselves are similar. Notice not congruent anymore, but similar, okay? And that means that there's a proportion between all their side lengths. So maybe we might have something like a 10 and a 5 here, which means it's a 2-to-1 ratio, okay? And then there's an 8 here, which means I would have a 4 here, right? Divide by 2. And then maybe, I don't know, 16 here and divide by 2 and get 8. Something along those lines where after we show that the triangles are similar, we can say that the corresponding parts are all proportionate while the side lengths, angles are equal. Okay, and that's really it. Okay, if we know two of the angles are congruent to 2 over here, then angle L has no choice but to be congruent to angle Z, because the one constant in all these problems is that triangle angles add up to 180 degrees. So you just need 2, and that's why it's a 2-letter acronym for the first time. AAA is technically what we're talking about here, but you just need 2 of them. Okay, so that's going to bring us to some practice problems. A lot of the problems here are determine whether they're similar or not and provide reasons. So we have these 2 right triangles here. We're going to determine whether they are similar, and then it says we're going to write a similarity statement. And that's just corresponding and making sure our letters are in the same order, which we've done for congruence in the past. So we recognize that this means this is a 90-degree angle, and this is a 90-degree angle. So far, so good. At least we know they're the same type of triangle. Otherwise, this wouldn't have a shot. But we have 90 and 26. We'll add those and get 116 and subtract that from 180 to find the measure of angle E. All right, we got to find the missing pieces of information about these triangles. So what's that? 64. So that means the measure of angle E is 64 degrees. Okay, well, sure enough, look at this. We have a 64 and a 90. We have a 64 and a 90. That means that this is no doubt 26, and we didn't even need that information, right? Because I have an angle that corresponds with an angle. So to answer this question, we would say, yes, they're similar, right, by the AA similarity theorem, just like that. And then our statement would be triangle. Now you got to match up the letters here. Let's go CDE. Doesn't matter how you start. But it does matter how we complete this. So CDE is similar to, and I'm going to match this up, it's going to be KGH. All right, because I started with the 26-degree angle here. I'm going to start with that here, KGH. Beautiful. Oops. All right, so that's what it means by determine and write the statement and explain. And this is a good enough explanation for now, as that's the angle similarity theorem. Okay, so show that the 2 triangles are similar. Here we have, like we often do, we have overlapping triangles. So this is where, it becomes a little bit more challenging when you have things that are overlapping. So we have triangle ABE is the smaller one, and then triangle ACD, which is the larger one. So they share angle A, okay, and that, if we were to write a proof here, which it doesn't tell us to, but let's just consider what would happen if we did write a proof. It would be angle A is congruent to angle A by the reflexive property, okay, because they share that angle measure. It's on top of itself. So yeah, if one of them is equal to itself, and then 52 here and 52. That means both the angles, the smaller one and the larger one, have a 52-degree angle, and angle A they share. So this is going to be yes by, again, the angle-angle similarity theorem. We don't care what angle E and angle D are. They have to be the same, according to the math here, because these triangles add up to 180. All right, angle SVR, so we're traveling SV towards the vertex here, are UVT. Are they similar or not? Well, based off of some instincts, we should immediately go ahead and label these vertical angles being congruent. All right, and we're going to notice that these lines are parallel, which creates a set of transversals here. Another thing that we should start to instinctively notice is like this angle right here is congruent to this angle right here, and that's because of alternate interior angles. I could also say S and U are congruent, but at this point I'm done. I can say yes, angle-angle similarity, because I only have two of them. I could go ahead and, yeah, you're absolutely right, I can go ahead and label this angle right here with three of them, and this angle right here with three of them, because those are congruent as well. But considering we don't need to, let's not even bother. Okay, we know that those have to be equal. Angle-angle theorem. That's it. Easy peasy. All right, so here we go. Show that these triangles are congruent. Write a similarity statement. Well, yeah, here you have an angle. Ooh, this is a little weird, actually. This would have to be 60, 60, 60. So that would be what we call an equilateral triangle. Okay? And this would have to be 60, 60, 60, even though they don't have the same number of tick marks. So for this question, I would say yes, they're similar. Because of angle-angle similarity theorem, once again. Hopefully we come up to an example that's a no, right? We haven't seen a no yet, but you'll clearly see it because the angles won't be the same. It also says write a similarity statement, and for this one it doesn't matter which ones we correspond. So let's go FGH is similar to triangle QRS, just to keep it consistent. That's it. CDF is the left-right triangle, and DEF is the right triangle. And so this one's 90 and 32. So if we go ahead and solve for the missing pieces of these triangles, I have a 90 and a 32. All right, we add that and we get 122. Subtract that from 180. This is just some quick math over here. That's going to be 58. Okay, so that means that this missing piece is 58 degrees. But it doesn't necessarily mean that this is 58. However, we do have a 58 here. So I have a right angle and a 58, and I have a right angle and a 58. So once again, this is yes because of angle-angle similarity theorem. I don't care about the 32-degree angle. This right here, this angle that I'm pointing to, has to be 32. All right, different sizes, but they are similar. They are proportionate. All right, lastly, we have this typical flagpole problem in math, right? You have it's casting a shadow that's 50 feet long. So here's the shadow, 50. Okay. At that same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. All right, so already we see some converting of units happening here. So we're going to have to take care of that. So we have this lady standing. Okay. This is an exaggerated drawing because she's definitely not 2 floors tall. So we can already anticipate what shapes we're going to get. We're going to get overlapping right triangles because the flagpole is essentially standing straight up, and we're going to assume the lady is standing straight up. So I'll grab another color, and we'll make her stand straight up. There you go. Okay, so with that said, let's take a look at the math again. It's a 50-foot shadow on the bottom. That's representing this entire length. So I like to use these markings. Some of you in engineering are very familiar with these types of markings on diagrams. It's good to use. So that's 50 feet, and she's 5 feet 4 inches. Okay, so 5 feet 4 inches means that she's 5 feet 4 inches, 4 out of 12, so she's 5 1/3 feet. Right? Writing it that way is a little bit better than writing 5 feet 4 inches. I got to get it into one numerical value, so that's her height. She cast a shadow of 40 inches. 40 inches, we have to figure out how many feet that is. 40, how many times does 12 go into 40? That goes into 43 times, 36, remainder of 4. So it's 3 1/3. So her shadow is 3 1/3. And that's from here to here. Question is, how tall is the flagpole? We're going to call it x. All right, so we'll set up a proportion here. So we're going to have x goes to 50. And 5 1/3 goes to 3 1/3. Okay? So I'm going to get rid of all this stuff. We don't need it anymore. But basically, I could look at my answer choices, and I know that my answer has to be in feet. Otherwise, I would have made this all into inches, which really would not be fun because then you'd have to change all these into pretty big numbers. So it's okay. I'll turn these into improper fractions. That might help. We have x over 50 is equal to 16/3 divided by 10/3. And when we're dividing a fraction by a fraction, I will multiply by the reciprocal. X over 50 is equal to 16 over 3 times 3 over 10. 3's are going to cancel, which is very magical. 16 over 10 is going to turn into 8/5. So x over 50 equals 8/5. Okay, multiply both sides by 50. 50 divided by 5 is 10. 10 times 8, 80. So your answer is C. All right, and that's all for section 6.3, focusing on angle similarity theorem. I'm going to post some practice problems that you can work on just to familiarize yourself with the first similarity shortcut.